Today we are going to cover Section 8. Section 8, we are going to talk about the beginning things for factoring a polynomial. As we look at factoring a polynomial, we're going to be able to identify a greatest common factor. That's one thing that we're going to be able to do. We are also going to look at we're going to do factor grouping. We're going to work with that. And that pretty much is going to be it. Factoring the greatest common factor, and we're going to be looking at factor by grouping. Just so that you're aware, do you remember how we've talked about in times past that adding and subtracting undo each other, multiplying and dividing undo each other, raising something to a power and taking the root of the number undoes each other? Well, factoring is a process that, in essence, undoes multiplying. And if you think back to dma060, another concept that's going to come into play is using the distributive property. Let me give you an example. If we were to have had, let's say, 2 times 3x plus 5. If you had been given this back in your dma060, you would have used the distributive property. The distributive property to multiply. So 2 times 3x would give us 6x, and 2 times 5 would give us a plus 10. What we are going to do in this section is you will be given 6x plus 10. You will be asked to factor this, and the first thing to do is to find the greatest common factor. So when I look at a 6 and I look at a 10, they're both even numbers. So 2 is going to be my greatest common factor. When I factor 2 from 6x, 2 goes into 6 3 times, and I still have the letter x left. 2 goes into positive 10 5 times. So do you see how I just took what we had known how to distribute before and get an answer, and that's the way we used to leave our answer. Now we're going to be given polynomials, and we're going to be asked to factor it. For this section, we're going to do some basic factoring. In sections 9, 10, 11, 12, we are going to factor trinomials specifically in a certain form. We're just going to have general items in this section that we're going to be factoring, okay? So the first thing that we're going to look at, a moment ago, I said we had to find the greatest common factor of, for all of these, we're going to find the GF of items. So let's take our first one, and let me give you two numbers. I'm going to give you the number 30 and 45. For the numerals, I'll show you longhand how you can do this, but I'm not going to expect you to do these longhand. I'm going to show you how to do these on the calculator. If I were to factor the number 30, 30 would be 6 times 5. 6 can be factored as a 2 times 3 is 6, and then 6 times 5 is 30. For a 45, I would have 9 times 5. So the 9 is going to be 3 times 3 is 9, and 9 times 5. So if I factor to prime numbers, I could then look and see what do they have in common. This has a 2, this one does not. So it's not in common. The 30 has a 3, the 45 has 2 of them. I can only use one of those for the 45. They both have a 3 in common. Both of them have 1 5 in common. So 3 times 5 would give me 15. So my greatest common factor for these two numbers is going to be the numeral 15. Let me give you 3 different numbers. Let's say we have 15, 18, and 16. And I need to find the greatest common factor of these numerals. The factors to get 15 would be a 3 times 5 is 15. 18 would be 9 times 2. So that would be 2, and the 9 would be a 3 times 3. 66 would be 6 times 11. So that would be 2 times 3 times 11. So if I'm trying to determine my greatest common factor, they do not all 3 have a 2. So I can't use the 2. All 3 of them do have one of the 3 is common. They don't all have a 5 nor an 11. So for this one, the greatest common factor is simply going to be 3. Now, let me show you how to do this on the calculator. So let me make a note here. We're going to do calculator steps. Okay. So if you will, we'll go to our calculator. And if you have your calculator in front of you, please take it out and press the buttons and go through these steps with me. I'm going to press the button Math. And then I'm going to use this right arrow because where it's black over the word math, I want to move it over to NUM. So you're going to arrow right. So let me write these down. Math, and I'll put a square around it so you'll know it's a button. And then you're going to press the right arrow key to go over to NUM, okay? Now, as we see all of these things here, we're going to choose number 9, where it says GCD. GC is greatest common. We would use the word factor. I honestly do not know what their D is representing. Maybe it's a Latin term for factor in Latin, I'm not sure. But we're going to choose number 9. So number 9, the one that has GCD, is the one that we're going to choose, okay? So we press number 9. Now, when we get this on the screen, we can only use 2 numbers at a time. So for the first one, I'm going to type in 30, 45. Let me make note, only 2 at a time. So for this one, we did 30. Here's the comma. Above the 7 is the key for the comma. The 45, and then close your parenthesis, press enter. So the greatest common factor for these two numbers is 15. Factor is 15. Now, when I do that same process with this problem has 3 numbers. So the beginning steps are still the same. So I'm going to put repeat, and we're going to repeat these, and I'm putting the little asterisk by. Then when we get to where it has GCD, I'm going to do first the numbers 15 and 18. So math, and do these steps with me. Arrow right, choose number 9, and we're going to type in 15, 18. So we're going to type in the first 2. Now don't do this, but I'm going to show you. If I were to have typed in all three numbers, it's going to give me an error message. So that's why I'm telling you, you can't type all three. This is the message that you're going to get. So let me come back to where I should be. I'm going to type in the first two, the 15 and the 18. It's going to give me an answer for the first two, which is 3. So this answer is 3. I'm going to repeat the steps, and this time I'm going to put the answer we just got, which was the 3, and I'm going to, so let's do that together. Math, arrow right, choose number 9. Let's use this answer 3 that we just got, comma, and then our third number was 66. And close your parenthesis. And after that, I'm just pressing enter for it to process. So for this one, the greatest common factor would be a 3. So when they give me 3 again, that's going to be the GCF for all three numbers. For this one, the numbers we had were, let me make note, 15. Oh, it was here on the side, 15, 18, and 66. You're not always going to have just numerals, but when you do have numerals, please, by all means, use your calculator. These are going to sometimes be really large numbers, and you don't want to have to go through the tedious process of factoring everything. This will give you the correct answer every time, so use those calculator steps. When you have just variables, though, it doesn't work quite the same way. Let's say we have an x cubed, an x to the 5th, and an. If I want to find the greatest common factor of these, the first one has 3 x's, the second one has 5 x's, the third one has 2 x's. So when I'm finding the greatest common factor here, I have to find the number of x's they all have in common. They all have 1, they all have 2. This one does not have a third, a fourth, or a fifth. So for this one, the greatest is going to be x to the second power. What if we have multiple x's and y's? Okay, let's say we have x squared y to the 4th, an x with a y, and an x to the 4th and a y to the 2nd. Okay, and I'm going to do it so my columns will line up. Here I have 2 x's. This one I have 1 x. This one 4 x's. The first one up here I have 4 y's. The second one I have 2 y's. And this one I have 2 y's. So when I'm looking for the greatest common factor for this, they all have 1x. They do not all have 2, 3, or 4. This one only has the 1. They all have 1, 2 y's. They don't have a third and a fourth for all of them. So for this one, my greatest common factor is going to be an x and then over the second power. Just keep in mind, you're going to use the smallest exponent for the variable in the common factor. It can't be the largest one because this had like 4 x's, so x to the 4th is not in common for them all. But if you look, the least, the most that they all can have in common is that single one. Here, 2 of them have only 2, so it's that smallest exponent is what you're going to utilize. Now let me put it together where we have numbers and variables. Okay, so let's do one where we have a combination of those. Okay, so let's say I'm going to give you 21 m to the 7th n, 18 mn squared and 45 m to the 6th. So when I'm looking to find the greatest common factor, I'm going to do the calculator first. Do calculate steps. Remember, it was math, arrow right, m, and then you're going to choose number 9 where it has greatest, this GCD. Okay, so let's do that. We got 21, 18, and 45 are our numbers. So let's clear this out. Math, arrow right, number 9. My first two numbers are 21 and 18. My common factor is a 3. I've got a third number though. Math, arrow right, number 9. Let's our answer we just got. And then we're going to use our third number, which was 45. So the numeral that we have is going to be 3. So 3 is the greatest common factor. For the variable, we're going to use the smallest. Okay, M, M, M. They all have M's. This has 7, this has 1, this has 6. So the smallest would be a single M. Now for N's, 1 N, 2 N, no N's. If there are no N's, then this one does not have it. It's not going to be part of the greatest common factor. And we're done. Okay? So all we're going to do to start with is you will have a skill and drill practice of finding just the greatest common factor. Now, when we learn to factor a polynomial, when we get to our section on trinomials, after everything's in the right order, the first step is to factor the GCF, if there is one. Factor out the greatest common factor. So what we're going to have that's going to happen for us is we will be given a polynomial that has several terms, and then we are going to factor out the greatest common factor. So let's start with a simple one. If I were to have 3m plus 12, I would just, if you wanted, I would just say use your calculator and you can find the GCF. This is a simple number. You probably know the greatest common factor of 3 and 12 is just going to be the number 3. So if I factor out a 3, what I would have left here, the understood number 1 and a letter M. 3 would go into 12 4 times. If you check by multiplying backwards, it's going to give you that number that we just had there. Let's say I gave you 5x minus 35. These two have in common the number 5. What I would have left here would be an x, and 5 goes into 35, that would be negative 7. 5 times x is 5x, 5 times negative 7 is negative 35. Okay, let's do one that has a little bit more to it. Let's say we have 20x to the third minus 10x squared plus 5x. I have 3 terms. The common factor has to be the same for all 3. A 20, a 10, and a 5. They're all multiples of 5. 5 is going to be the largest numeral factor. We have 3x's, 2x's, and 1x. So the smallest exponent would be 1. All of them have at least a 5 and an x. Then we take this greatest common factor, CF, and we divide it in terms. So 5 goes into 20, four times. When 1x is taken away from 3, I'm left with x to the second. 5 goes into negative 10, that will give us a negative 2. If I take 1x away from squared, I have just 1x left. Now notice, 5x into 5x. That 5 goes into 5 once, and there's a pair of 1x's. This is identical. I can't leave it blank. I still have to put the numeral 1 as a placeholder. To check your work, always go 5x times 4x squared is 20x cubed. 5 times negative 2 is negative 10. Here's my two x's. 5x times 1 is 5x. Let's do one more. Let's do one where we have multiple values. So let's say we have 4x to the 5th y cubed plus 12x to the 5th y squared minus 28 x to the 4th y squared minus 4 cubed and a y. Okay, we've got four numbers. Now two of the numbers are the same. They're both 4s. So actually 4 could potentially be the biggest common factor. They're all even numbers, so 2 goes into everything. But let's see if that smallest number, does 4 go into 12? Yes. Does 4 go into 28? Yes. So for our GCF, we're going to have a 4. For the x's, we have 5, 5, 4, and 3. So the most x's they all have would be 3 x's. As we have 3, 2, 2, and 1. So the most y's they all have would be 1. So my greatest common factor is 4x cubed y. Then I'm going to say 4 goes into 4 once. So that would be, you don't have to write the understood 1, but I'm going to put it there. If I take 3 x's away from 5, I'm left with x to the second power. If I take 1y away from 3, I'm left with a y squared. So you really wouldn't write the 1, you would just have x squared, y squared. 4 goes into 12 times evenly. 3 x's from 5 leaves us with an x squared. 1 taken away from 2 would be 1. 4 goes into negative 28, negative 7. 3 from 4 leaves me with 1x. 1 from 2 leaves me with 1y. 4 goes into 4 one time, so that's a minus 1. 3 x's, that is the same. The 1y is the same. So this whole last term matches the GCF. So we have to have the 1 as the placeholder. And then that's where we would stop. So when you're doing parts of the skill practice, they're wanting you to factor out the greatest common factor, and then you're done, okay? One other thing, let me just point this out. If you have something that starts with a negative, let's say we have negative 7. We never want to start polynomial, so we would factor out a negative 1. So if I factor out a negative 1, what's going to happen is my signs change. To get a negative x, I would have to say negative times positive is negative. To get a positive, I would have to say negative 1 times negative 7. Negative times negative would give me a positive. So the signs are going to change for what was up here when you factor out that negative 1. In your workbook, I'm going to skip page 6-63 for a moment. I'm going to come back to it. When they do factoring, that particular problem to me does not make sense until we talk about the next part, which is factor by grouping. So we're going to talk about factor by grouping, and I'm going to come back to the two problems on 6-63. Factor by grouping, we're going to use with 4 terms. If you have 4 terms, this is the way we're going to factor. So let me give you a problem. And in our problem, we have, let's see, we're going to have 2x plus 6 plus ax 3a. When we have four terms, it does not matter the order they're in. Leave the problem the way that it is. What we're going to do is we're going to factor the first two, we're going to factor the last two, and we're going to keep the sign in the middle exactly as it is. We're not going to change that middle sign. So with these first two terms, what these both have in common is the number 2. They're both even. If I factor out a 2 here, I'm left with just an x, and 2 would go into 6 3 times. So you factor the first two terms and write what you would have left as if you were doing a single binomial. Keep the sign that's here. When I look at these two, what they have in common is the letter A. When I factor out an A here, I'm left with X. When I factor A out here, I'm left with the number 3. Now, what I want you to notice is, do you see that both of them have X? X plus is their common factor. What's in the parenthesis is the common factor. We then need to figure out what's going to make our second factor. What goes here is going to be the GCFs. So here we factored out a 2. Here we factored out an A. So what goes here is going to be the 2 plus A. So the GCFs go here in the second parenthesis. So now we have two binomials. They're in parentheses beside parentheses. Factors are when you have numbers that you multiply by each other. If I need to check this, I'd have to actually FOIL it to go back to check. Okay, let's do another one. Okay, here I'm going to give you a 3 plus 4xy minus 3x minus 4y. So I'm going to give you four terms. We are going to factor the first two, the last two, and keep the sign that's in the middle. These numbers only have in common the single letter x. If I factor out x here, I'm left with a 3 and an x. Here, I would be left with a 4 and I'm going to use the sign minus. Now, these two, I do not see anything in common. Not a number, not a variable. So if there's nothing in common, we're going to use the numeral 1. Now, if you have a minus, always just don't put a sign here yet. It's going to be a little tricky. 1 goes into 3x, that would be a 3x, and that would be a 4y. But as we check, working backwards, a negative times a positive is a negative. A negative times what gives me a negative? It would be a positive. So that sign is going to change and be a plus. When I do my answer is going to factor into two terms. The common is the 3x plus 4y. That's the common factor. Then what was in front, that x minus 1, that would be the GCS. We're going to make up the second parenthesis. Okay, let me give you one more, and this one's going to have even one more step to it. For this one, we have, let's see, 4x to the 4 plus 4x cubed minus 20x squared minus 20x. So if I want to factor this, the first thing I'm going to do, always see is their greatest common factor. Instead of doing two terms, we're looking for a GCF in general. 4, 4, 20, 20. 4 goes into every number, so 4 would be a greatest common factor. 4, 3, 2, and 1, all of them have at least one x. So the 4x is going to be the big major GCF that's going to get factored out. When I factor 4x from here, I'm left with x to the third. 4x from this leaves me with x squared. 4 goes into negative 20, that would be a minus 5, and there's still 1x. And 4 into the negative 20 is going to be a minus 5, the x canceled out. So now, GCF I did first, that was here. And now here I'm going to do factor by grouping.